Okay, awesome. Welcome. Thank you so much for coming. So we're frequently asked by customers how we at AWS can scale and operate at scale while performing security reviews for everything we launch. So today, I'm going to focus on the practices that you can apply to your own organization. So my name's Leah Vader. I am a security engineer in our AWS AppSec org. I've been with AWS for 10 years and doing multiple different roles for the last few years, working with our internal service teams, helping them build and launch securely. So there's a few things I want to cover today. One of our first learnings is that while we are a large security organization, we can't scale just by headcount. You can, but it's very, very expensive. Don't recommend it. Instead, we focus a lot on implementing practices and creating mechanisms that allow us to maintain security and speed simultaneously. And one thing before we move on, I do want to address is, I understand that not every AWS AppSec practice that we have will translate to your environment. So I've curated this talk today by pulling out the things within AWS AppSec that we do that I think will scale across almost all of our customer environments. So there's a few things I want you to get out of today. One, I want to talk about the mechanisms and processes that we use for scale and creating good security outcomes. And I want to talk about how we embed security into the development process with secure design principles and building automated guardrails. And then I want to also talk about, actually the first thing I'm going to talk about is establishing a security culture, all while maintaining business velocity. I was chatting with a few of you guys earlier, and one of the themes I heard was we want better tooling to make sure that, one, we know what our developers are doing, and to stop them from doing silly things. I want you to change your mindset a little bit with that security culture. So we'll talk more about that. Because ultimately, good application security is enabling innovation rather than hindering it. So let's first just start with where we are today and how we got here. All right, when we look at the evolution of application security, we can break it down into several phases. And most of you have probably experienced this. First, we have the traditional security model. This is the gates and the guards. This is when security is the department of no. So AppSec's at the end of the development cycle, then we conduct the review once all the development's done, and then we find vulnerabilities, we have findings, and we send it back to the application team for rework. So this creates friction, it's slow, and frankly, it doesn't have good security outcomes. So then came the DevOps era, and that came with new challenges. DevOps teams are moving faster than ever, and security teams were still using old models. So it created this false choice between speed and security. So you just move quickly and accept risks, or be secure but slow to market. So we've learned security must be an enabler and a partner. Security teams should provide tools, automation, and guardrails to help builders build securely from day one. And we embed security throughout development, not just at the end. The most successful AppSec programs today were not focused just on vulnerabilities and compliance. We're focused on enabling teams to move faster and launch securely. So how do we do this? The key is being strategic about where you focus your security resources. I think you guys already know you can't scale AppSec by manually reviewing every line of code. It doesn't work at scale, and you're not going to build trust with your builder teams. So first, you want clear criteria for what needs a security review and what doesn't. So when I talk with customers, this is a really common question is, do you actually review everything? And the answer is no, we don't review everything. But we have clear criteria of what needs a review and what does not. And you want to be very explicit about both sides of that equation because you want to eliminate guesswork and prevent any unnecessary delays. So instead, I suggest taking a risk-based approach to AppSec reviews and focus intensely on changes that impact your customer trust. So these include things like modifications to authorization, and changes to how you handle sensitive data, or introducing new endpoints. Those are really like obvious ones there, but those should require a security review. And lower risk changes, things like UI tweaks or bug fixes that don't affect things like authorization. Like you still apply your security checks, like your scanners and your guardrails, but you don't necessarily need a manual security review. And this allows your security engineers to focus on things that need strong security judgment. I also suggest empowering your teams, your developer teams, to self-identify what needs a review. Train them to recognize security-sensitive changes, and then give them tools to make informed decisions about when to engage your security teams. That said, you should be looking at significant changes in your AWS environment and your code bases, because large changes often warrant a closer look, and you want to ensure that your process is not circumvented. And lastly, this is not a static process. It should be dynamic and data-driven, just like your business, and it's going to evolve over time. And even within AWS AppSec, it's continuing to evolve and improve. All right, so let's walk through a fictional AppSec review. So we're going to launch a new AWS service, and this is called AWS SOC Matcher. Because like we're at a security conference, right? We've got the expo hall, and whenever I go to these conferences, there's always SOCs, right? You collect all these. Has anyone gotten SOCs yet? Oh my gosh, like half the room, yeah. So we collect all these SOCs. We go home. They're all different sizes, all different like shapes, colors, whatever, and they don't match. So we're going to build a service that will create an inventory of our SOCs. We'll use GenAI to match it, and this will be our new AWS service, and we're going to walk through that process. Now, to be clear, this is fake. This is not a real AWS service. We absolutely don't need this service, but it'll be a good example service for us to walk through. So let's start with what I think is the most important part of our security process. And that's our culture of security. And this is what I was talking about at the very beginning, where I think if you focus a lot on your culture of security, a lot of your other AppSec processes will become a lot easier. But this will take time. But let me talk through how we think about it. So at AWS, you often hear us say, security is our top priority, and security is everyone's job. And the first thing is, executive support is non-negotiable. So the idea that security is everyone's job can't just be a poster on the wall. It has to come from and be consistently reinforced by senior leadership. And when your CEO and leadership team prioritize security in both words and actions, it will cascade throughout your organization. Second, you need to implement truly distributed ownership. So don't just say security is everyone's job, make it actually everyone's job. Like in our job recs, requirements for SDEs, we actually include security as a part of that. And your security team should advise on risk for the organization, but your business units and your product teams must own the risk and risk-related decisions for those respective areas. Like the developers own the software, the developers own the threat model, and they have strong ownership of the security of their systems. And third is foster psychological safety in your organization. I know when I first started AWS, this was like a weird one for me to wrap my mind around. But your people need to feel empowered to speak up about security concerns without fear of repercussions. So you can build the most advanced and sophisticated security tooling in the world. But it won't help if you have a security engineer who sees a concern and doesn't speak up because they're afraid of delaying a launch. So we celebrate those who speak up, whether it be a security engineer, whether it be a developer, because we want to hear those concerns. And there's no repercussions, even if they're wrong. Even if they speak up and say, hey, I think this is a problem, and finds out it's not a problem, there are no repercussions because we want to encourage that behavior. So finally, we invest in communication and education. And there's a lot of ways we do that in AWS. But in AppSec, one way we do that is through our Guardians program. So let's talk more about that. Does anyone here have like a Guardians or Champions program? Okay, good number of you. Cool. So I don't know if you learned about that from AWS, but I'm going to talk a little bit about how we do it. So we are seeing more and more customers do this successfully, which is great. These are members of service teams who volunteer to be consistent champions for security within their own teams. Now, I want to be clear about this. These are not replacements for AppSec engineers, nor are we trying to shift our workload, I mean AppSec workload, onto the service teams. What they do is embed security early in the development process. So we spend a significant amount of time training these guardians on security principles, practices, how to threat model effectively, anything relevant to their work. And this pays off by bringing security awareness directly into the team's daily conversations. And so we have guardians attached to, like one or more guardians attached to every service team, and they participate in design discussions from the beginning. And they're asking the right security questions, because we've trained them. And so when the ideas are still forming, we're bringing security early. And they also know when to engage AppSec engineers if they need deeper guidance. Because AppSec engineers, for us, actually get involved at the design stage. And again, the point here is not that we're pushing AppSec work onto service teams. It's rather we're creating a collaborative bridge that helps teams think about security earlier and making the right design decisions from the start. Now, at AWS, our guardians don't have the authority to sign off on AppSec reviews. This remains the responsibility of us, the AppSec engineers. That said, like I understand we operate at a pretty large scale, and we have a lot of engineers. And not all organizations can operate at that scale. So some of you may find it works better to empower your security champions to conduct and sign off on certain types of reviews. So if you choose this approach, my strong recommendation is to be explicit and intentional about when and where this happens. Document it clearly, and document which reviews require AppSec engineers and which can be handled by trained guardians, because implicit rules will create confusion. Okay, so we covered our security culture. Let's start building our SOC Matcher service. So I'm going to break this up in the process of our service team's development lifecycle. I think it's important to note that this isn't a completely linear process. Like if you've built software, you know that occasionally you're still designing components while you're actually coding other components. And you also know that like threat modeling is happening throughout this process. And lastly for us, the security engagement is happening from the design phase up until we sign off on the review. So let's dive into the design phase first. We're going to talk about security controls. And actually, before I dive into that, has this group all like defined sets of like security controls of like this is what good looks like in our AWS environment? Or are we still doing that? Okay, I saw like one tiny little hand like maybe. All right, so let's talk a little more about that. So at AWS, we develop security standards for our services that we believe are central across nearly every environment. And we incorporate these standards into our AppSec process. It's in our knowledge base for our developers or our builders to review. And it's part of our threat modeling process. And oftentimes, these standard security controls serve as mitigations in our threat modeling. They're not arbitrary. They're very intentional and thought out. And when we're creating these standards, we focus on the security outcomes and what we're trying to achieve. And then we ask, how can we make these security faults? How can we automate them? And how can we build detections around them? So I'm going to give you a few examples. We have CloudTrail and S3. So for audit logging, with CloudTrail and ensuring S3 buckets have proper access controls, we've built these directly into the account provisioning process. And then we've enforced them automatically through both preventative controls and detective mechanisms. And then, however, for the principle of least privilege, this requires a little more human judgment. So we can use things like IAM Access Analyzer to help guide these decisions, but we still do use human judgment to ensure we've actually achieved least privilege. Now, I noticed there weren't very many hands raised when I said, does everyone have their standard set of security controls of what you want in your AWS environment? There was like a half a hand raised. So if you want to start developing your own security controls, I suggest looking at the well-architected pillar, or a well-architected framework, and there's a security pillar in there. It's a really great place to get started with practical guidance on what good looks like, and it's based off of like what our security architects who work with customers every day have found works for our customers. Let's talk about how you can effectively automate these controls in your environment. So AWS Config and AWS Security Hub are services that can help implement a similar approach to what we use internally in AWS. So config begins by recording and normalizing changes in your environment. And then you can apply rules and conformance packs to evaluate the compliance of your environment. These work as guardrails, so you can let your teams move fast while staying secure. You can also build your own customized rules with your logic using Lambda functions and guard rules. So that means like if you don't see a managed config rule that works for you or that aligns with the security standards that you've set, you can go write your own. But you don't necessarily have to do this from scratch. We've packaged a lot of these in the conformance packs, but also Security Hub uses config, and they have their own sets of security standards, like the AWS foundational best practices, and they can deploy config rules for you that probably align with those security standards that you're looking for. And then finally, you can automatically remediate using config if that makes sense for your particular control. It's like a good example of where you might want some automatic remediation would be like if you found a resource that's unexpectedly open to the world, you may want to remediate that immediately and automatically. All right, so we covered our initial controls, defining and automating those. But our SOC Matcher service is still in the design phase, and we need to start threat modeling. So for us in AWS, I mentioned this before, our service teams have strong ownership of the security of their services, and they're the experts of what they're building. This also means they own the threat model, and the guardians are deeply involved in this process. But our AppSec engineers, we help review the threat model. We make sure we have the appropriate threats and the appropriate mitigations, but the overall ownership lies with the service team and the guardian. And there's many ways to do threat modeling. You should choose what works for you and your organization. But our approach starts with ShowStack's 4-question framework. So first, what are we working on? This just helps understand the system you're building and what matters for security. We ask teams to create a diagram, like a data flow diagram. And then we also have them document the key assumptions too. This keeps everyone focused on the same thing and avoid wasting time on things that you can't control. Next, we ask what can go wrong. This is where you find the threats in your system. And there is no perfect list of threats. You need to think deeply about your service and brainstorm with your team of like what really could go wrong. And if you need help with this, methodologies like Stride can help give you categories to think about. And then what are we going to do about it? These are your mitigations. Now, when you're thinking about this from an AWS infrastructure standpoint, each AWS service has a security chapter in its documentation with guidance that can help you identify what those mitigations are. And then lastly, did we do a good job? The goal is to get better at threat modeling over time. This comes from practice and learning. We also have a threat modeling workshop called Threat Modeling the Right Way for Builders. We ran it this week. I believe that was on Monday. So if you missed it, you can find it online. Also, to help with our threat modeling process, we built a tool internally called Threat Composer. So we found a lot of value in Threat Composer internally. And so we ended up releasing it externally. Actually, the same thing with that workshop. We ran the workshop internally. Our AWS service teams really liked it, and we realized that our customers would like it too, so we started running that externally. So Threat Composer, it's a tool that makes threat modeling faster and more consistent. I really like it. My favorite part about it is it helps you write clear and useful threats. And I'll show you what one of those looks like in a moment. And it's a full tool, so you can store all your threats, and at the end you'll get a threat model in a human-readable format and a machine-readable format. And then there's a dashboard to track your progress and identify coverage. So here is an example of threat modeling the SOC Matcher tool. This might be kind of small print, so I'll read it to you. A threat actor with a network path to the CloudFront distribution can submit a large number of resource-intensive requests, which leads to the API being unresponsive to callers, resulting in reduced availability for the SOC Matcher API. And then you can notice in this tool, we can link one or more mitigations to this threat, and the service team would then go and implement those, and attach any useful metadata. And at the end, you have a full threat model. And this is an example of the dashboard I mentioned earlier. And so this is, and there's a QR code if you're interested in this tool. This will link you to GitHub, and you can go actually host this yourself. I see some phones, so I'll pause for a second. Okay, we're good? All right, so let's check in. SOC Matcher update. We have our security controls. We're in active conversation with our security engineer. We're continuing to work on threat modeling, but we need to write code. So let's talk about how we do this securely. So we often talk about paved paths. These are paved paths. You might hear this term as like golden paths. Also secure defaults. There's different ways to think about that. So we have teams that work with our builder experience organization, and our builder experience organization is our internal org that creates all the builder tools. And so we have teams that work with them to build paved paths and secure defaults. And you can do something similar using tools like CDK constructs and CloudFormation templates, or whatever preferred tool chain you have. And actually, is anybody using CDK today? Okay, handful of you. I do want to do a quick call out because there was a recent release. I don't think they made a big deal about it, but I'm super excited about it. It's called CDK Blueprints. So this actually allows you to inject secure defaults or properties into your L2 constructs. So like your S3 bucket, you can inject specific properties and creating thereby secure L2 constructs. So if you use CDK, look this up afterwards. It's very cool. So the goal isn't perfect standardization. It is making the secure way the easy way, not forcing a rigid secure pattern. So this kind of goes back to our security culture. We're not trying to force service teams down a specific path. We're just trying to make security easy for them, and then we have guardrails later. So think about it this way. Every service team has a unique set of requirements, especially in AWS, right? We're launching everything from like contact centers to IoT services and so on. And if your paved paths don't work, your development teams will simply work around them. And frankly, if it's not working, you want that feedback. You should be asking, why doesn't this work? And what can we change to give the flexibility while meeting our security bar? And you can look at tools like CloudFormation Guard, CloudFormation Hook as guardrails, but the key is flexibility. You want the guardrails, but you need to also give flexibility for your teams. Teams may need to modify your patterns for specific needs or step outside those common patterns. For example, you may have a paved path for DynamoDB as a data store. And our SOC Matcher team may want to use S3 for that data store instead. Allowing this flexibility while having guardrails to catch if a bucket's open to the world is a better experience for everyone. And will help you move faster. And finally, measure and report on the effectiveness of your paved paths. It's common for AppSec metrics to report on findings and risks, but we also want to have metrics around the success of your AppSec teams. And this means establishing open and continuous feedback mechanisms. Are your teams using paved paths? Are they finding ways around them? Why? And are they reducing friction and solving for the security controls that they're meant to solve for? This data will help you refine your approach over time. Because if you do take this route of creating paved paths, you're not going to get it right for the first time. You're going to need to iterate, get feedback from your builders, and continue with your process from there. So let's walk through at a high level how the development flow works for our builders. And remember, we want to meet the builders where they are and build security into their preferred and existing flows. And I say that is so important because if you don't and you force them down specific paths, they will just work around you. So for us, the builder writes code, and when they're ready, they use our standard development tooling to submit a code review. And a few things happen here. We have static code analysis that runs and is purpose-built for our AWS services. And once it's complete, the code goes to peers for review. So we always have one or more team members look at it, comment on it, and eventually approve it. And after any requested changes are made, the code can be merged. So let's take a step back into the development process. We're going to go over how we're bringing some of our internal security practices directly to you through Amazon Q Developer. So as we talked about, static code analysis is integrated into our builder tooling. But we've always operated under the principle that when we build something ourselves, our customers need these capabilities too. And we've consistently heard from our own builders that they really like the feedback from our tooling, but they want that security feedback sooner, like right in the IDE as they're actively coding. And that's exactly what Amazon Q Developer security scans can do. It brings real-time security analysis directly into their development environment. So you may be familiar with it from like the real-time code suggestions, but there's also security scanning built in there. So I'll show you a really quick example. So we have the infrastructure for SOC Matcher service. This is just CDK code. And we've got a DynamoDB table. We've got an S3 bucket. And I ran /review. And we can see on this left-hand side here that I have some code issues. And this is security or otherwise. So all in one place, so developers can get early feedback. And I can hover over identified code and get an explanation. And this is an example of that. So you can get guidance on how to fix with appropriate code samples, and you have the option to generate code. And this is great. And this is in the IDE for the developer, and they like this. But we also recognize that security needs to be embedded throughout the entire development lifecycle, like in the pipeline, which we also have. So you have options to doing this in your own organization. One approach is using Amazon Q Developer in the pipeline. So Q supports GitHub and Preview and GitLab Duo. Or if you prefer, we have lots of partners who provide excellent static code analysis tools that can integrate with your preferred pipeline. All right, if you haven't noticed yet, we haven't talked a ton about the actual security engagement. So this is ongoing from design to launch, but let's dive in now. All right, so at AWS, we've learned that effective AppSec begins before a single line of code is written. In our review process, I've said this quite a few times now, but our review process starts in the design phase. So first, we provide tools early. We already covered paved paths and tooling in the IDE, but we also have an extensive knowledge base. And all of our security controls are in there, along with additional like secure coding guidance and so on. And our builders can browse that, or they can interact via a chatbot that we built. It's directly into our security review tool to get the help they need. We also ask that our teams engage us early. Early engagement allows us to shape security decisions, which reduces friction for our builders later on. And we actually consistently hear from service teams that they get better outcomes with this proactive approach. As technology has progressed, we've adapted a model where our engineers specialize in sets of domains and services. So for example, we have security engineers who focus specifically on GenAI applications and services. And they're focused on understanding the unique security challenges in that space. We also have a team that focuses on the customer side of the shared responsibility model, diving deep into how our customers build on AWS and incorporating that into the AppSec process. This specialization allows us to provide deeper and more relevant engagements rather than generic security advice. And perhaps most importantly, we don't hope for security. We build mechanisms to ensure it. So we create processes, systems, and tools that make security outcomes predictable and consistent. And this approach scales far better than relying on heroic efforts or perfect execution every time. So I want to tell you about one of my favorite mechanisms, and that is escalation. Has anyone heard us talk about our escalation culture or escalations before? Okay, a couple hands, cool. So when I talk about security culture with customers, I often get skeptical looks when we talk about ownership. And like those skeptical looks are often because they don't necessarily, they normally say something like, I don't believe that your service teams always agree with AppSec, or that AppSec always agrees with the service teams. And we don't. So the next question is like, what do you do? And for us, the answer is simple. If something doesn't look right, and we can't agree on a path forward, we escalate. But let me be clear what that means at AWS. Escalation isn't about conflict. Creating a mechanism for escalation isn't about who wins an argument. It's about ensuring that we make the right decisions with the right input. And I acknowledge that sometimes escalations is a bad word in some organizations. Where I worked before, prior to AWS, it definitely was. And if this is your situation, my advice for you is still create the mechanism, but give it a name. Something else that's not escalation, at least initially, as you develop your security culture. So effective escalation gets the right decision makers involved. Because sometimes these security disagreements happen because the people in the room don't have the authority to make the decisions. And your escalation path should lead to those who do. Equally important is bringing the right data to these discussions. Escalations should be data-driven conversations about risks, potential mitigations, and the customer and business impact. And everyone's working from the same facts, creating better outcomes. And the goal is to always create the right security outcome for your customers. So we found that escalation creates faster feedback loops in the AppSec process, because escalation shouldn't drag on for weeks, adding people to CC on these long email threads. You want to get the appropriate parties in the room, virtual or physical, with the right information. So it should be the background of the service. What are we building? What's the problem? What's the risk? What's the impact? What are our paths forward? We should have several. And then what's the proposed path forward? This is the AppSec engineer writing, this is what I think we should be doing. And then the group goes and considers it. At AWS, we view escalation as showing strong security judgment and ownership, not a failure. And we recognize and reward that behavior. So we just talked all about that, but you may want a practical example. So let's go back to Sock Matcher. So we already know Sock Matcher service is like this fictional service that we are creating an inventory of socks, probably getting pictures, storing it in S3, so on. And in AWS, we enforce strong authentication and authorization. And as a customer, you can observe this through IAM, right? But the Sock Matcher service team wants to implement their own identity model outside of IAM. If you worked with our AWS services, you already know, like, this goes outside the bounds of how we normally operate. But there may be business reasons to do that. Like, I want my dad to use Sock Matcher service. And my dad does not have AWS creds. But this is not a decision that should be taken lightly. We want the right people to understand the service. We want the right people to understand the identity model. And this will all help to an outcome that's secure and makes sense for the service and the customers. We need this fast. And that's why we have escalations. This allows us to make the decisions. So an AppSec engineer, in this case it would be me, I'm going to write up the background. What is this service? What data are we dealing with? What's the risk? The risk of creating a new identity model. What's the impact? What are our various options and a recommended path forward? And I may say this is going to be a recommended path forward is we do support IAM, but maybe we also support some OIDC flows. And then we follow our escalation path. And we found that this gets us to the best security outcomes faster. But there's other mechanisms that we've actually talked about that you can implement. And the power of mechanisms is that they make security systematic and scalable. So think about it as operationalizing intent. So examples include creating a definition of launch blocking risks and building that into your security review tooling. And then building a mechanism in your tooling to ensure that launch blocking risks are actually resolved before launch. And then your secure by design or paved paths are mechanisms to start securely. Your automated guardrails are a mechanism that allow your security engineers to focus on more high judgment problems. So we talk about how we measure success and improve processes through metrics. I wanted to dive a little bit deeper into that. So first, when we're talking about metrics, my first advice is focus on security outcomes, not just activity. Measure things that show better security, not just how busy your security team is. And when you set up metrics, they shape how people work. So pick metrics that encourage the behavior that you want. And avoid metrics that encourage the wrong behaviors. So like counting security reviews might push teams to rush through them and hit targets. And that's not a good security outcome. And tracking total findings might stop teams from reporting issues and keeping numbers down. And those numbers alone don't show your AppSec program's impact. So let me give you some examples of metrics. Look at patterns in your findings. What are the common findings across teams? Like total finding counts, like as I mentioned before, doesn't tell you much. And finding issues is good. It means you're aware of the problem and you can fix it. Also be aware, as you improve detection, because you're going to be consistently, over time, adding more detections, more scanners, and so on, you're naturally going to find more issues. And if you were to graph that out, like over time, you'll see spikes. Like, oh, I added this detection, and we see a spike when that new detection is released. And that's a good thing. What helps most is seeing which problems keep coming back. Why do they happen? Is it just in certain cases? Is it certain teams? Are we all making the same mistakes? And then track how many teams are using your paved paths. This shows people are using the tools that you provide. And then ask, why aren't some teams using them? Are the tools helpful? Do they not work in certain cases? And when metric reveals issues, treat it like a system issue, not a team failure. Again, this goes a little bit back to like our security culture, but this helps teams be open about the security challenges. And as you build your metrics, ask yourself, do these drive the results that we want? Do they encourage good behavior? These questions help create metrics that actually improve security, not just fill dashboards. Okay, so we're going to check in and go over some quick takeaways. So first, start the security review process early with your builders. And engage during the design phase when changes create less friction and architectural decisions can still be influenced. And build tools and mechanisms for builders to get started securely. Remember, mechanisms operationalize intent. Don't just tell your teams to build securely, give them the tools, templates, and guardrails to make the secure path the easy path. And when security is built into your builder's development environment and workflows, it becomes part of how work gets done rather than an afterthought. And define clear launch criteria. Be explicit about what constitutes a launch blocking security issue versus what can be addressed later. And then create a mechanism for escalation paths. Disagreements will happen. That's normal. What matters is having a clear, efficient process for resolving them and bringing the right decision makers with the right information. And then track metrics on your business value, which we just went over. And finally, remember, the goal isn't perfection. It's building mechanisms that continuously improve your security posture while enabling innovation at cloud speed. Security is a journey, not a destination, and the most successful programs focus on continuous improvement rather than achieving the state of perfect security. Okay, let's move on. We're working through our review. We're getting findings attached to our review. This is part of our SOC Matcher service. And we have guidance on how to resolve these. And we can start to work to address these findings. But let's look at the tooling and automation that's creating these. So we're moving on to our security-focused tests, our scanners, and pen testing. So I'm commonly asked when I talk to customers about our AppSec processes, do you use centralized or decentralized tooling? And our AWS security teams own and maintain the core security tooling. The centralization ensures consistent security standards across the organization. It also means that we can rapidly deploy updates or add new detections without involving service teams. We learned that security tools are effective when we meet builders where they are. So remember how I talked about staying within the builder's workflow? This is one way we do that. So rather than forcing them to context switch, go to separate security systems, we integrate that directly into their environments and their workflows. And we try to avoid any extra onboarding for teams. This integration dramatically increases adoption and effectiveness. And as you're aware, the reality is that manual security reviews, while valuable, can't keep pace with the velocity of our modern development. And that's why we've invested heavily in automated scanners and tests that run continuously in our environments. This would be in pre-prod and prod. Obviously, I'm talking about pre-prod because I'm in AppSec. We're pre-launch. And we have way more than I can fit on one slide. But I want to give you some examples of how you can achieve a similar result. So we do authorization testing. And one way we do this is through automated reasoning with tools like Zelkova. And we actually turn around and give that back to you as a customer for you to use through IAM Access Analyzer. We also have continuous scanners looking for configuration compliance. And you can achieve something similar using Security Hub and config with config rules. And note, anything can be customized and can be done through a custom config rule. So if you don't see configuration compliance or any other tests that you want to run in your AWS environment, you can create that in a config rule or just schedule it as a Lambda function and event bridge. But you should also be adding your own detections. And you should be continuously learning from your past incidents. So we have processes in Amazon when something goes wrong, security or otherwise, where we ask the 5 whys. Why did this happen? And we have an answer, and well, why did that happen? And at the end, we start to ask ourselves, how do we detect this again? And if it ever happens, how can we remediate? And you should be doing the same thing, is if you have a security incident, start digging into it. Why did this happen? What failed? How do we make sure this never happens again? And then go write code to detect that again and remediate if at all possible. Now let's talk about security-focused tests. So this is a practice that can be overlooked, but it's really, really valuable. These aren't generic detections. These are canaries that you're writing specifically for your service, and your threat model is going to inform what these should be. So when you ask the question, what could go wrong? That's the question that should drive part of your testing strategy. Write tests that prove that your service behaves correctly, not just in normal conditions, but especially in conditions when someone's trying to do something they shouldn't. And then, this is so important, test the negative, because that can get forgotten really easily. So let me give you an example. I've got my SOC Matcher service, and we ask what could go wrong. Well, somebody could get my SOC data. I'm storing pictures in S3. We've got metadata in a DynamoDB table. I need to write a test that verifies that an untrusted identity cannot access my SOC data in S3 or Dynamo, while a trusted identity can access my SOC data. And we need to test both outcomes. And these can be canaries running continuously, because if I ever push code or there's an unexpected change, I want to know if any of that caused a regression in my security controls. And you can schedule these on your own with AWS Lambda functions and with AWS Event Bridge. Okay, now let's talk about findings. We built a system where findings automatically link to reviews, and they have risk-based prioritization. This automation ensures nothing falls through the cracks, and teams focus on the most important issues first. We fix any launch-blocking findings. But we also recognize that automated tools don't have the full context. That's why we allow engineers to use their judgment and influence the severity of a finding based on the context of the service or the data that we're handling. An example, like a finding might be medium severity in one context, but could be launch blocking in another, depending on like the sensitivity of the data that we're dealing with. Launch blocking findings require resolution before a service can go live. For us, there's no ambiguity here. If it's launch blocking, it must be fixed. And for non-launch blocking findings, we still maintain accountability. Each finding has an explicit owner and has an estimated completion date. This prevents the, we'll get to it later, go on the backlog syndrome. What I believe makes our approach particularly effective is that AppSec engineers are actively involved to ensure resolution, because we solve problems together, not in isolation. Security isn't throwing issues over the wall. We're rolling up our sleeves and working together with our service teams to implement these solutions. So overall, this leads to better security outcomes. So our SOC Matcher service is now written. We're working through findings, and we need to complete our penetration testing. At AWS, we have predefined criteria for when pen testing is required. This removes the ambiguity and ensures consistent application across our services. That said, we still value engineer judgment in this process to decide ultimately if a pen test is necessary. And then next, the AppSec engineer and the service team write the scope for their pen test. And that goes to the pen testing team. Additionally, penetration testing for us isn't a one-time event. We are continuously looking for changes and validating known good states, because systems evolve over time and we want to validate that. Now, this is one of those things where I acknowledge we have many security engineers and we can operate at scale. So if you're building or improving your own AppSec program and you don't have dedicated pen testing engineers, there are partners who specialize in this work. And there's many qualified security partners who can help you and implement that pen testing. They're probably in an expo hall, and you can probably get some free socks. Okay, so we made it to AppSec sign-off. Now what? So we went through our development, we used secure defaults, we used paved paths, we worked on our threat model, we built our mitigations, we wrote security-focused tests based off our service and the threat model. We had all our scanners run, static code analysis run, we had pen testing completed. We had findings and they got attached to our review. We worked with our AppSec engineer to resolve those findings. And now we're ready for the review to be signed off. So we move on to continuous monitoring and testing and improvement. So this is a really good point for a retrospective, asking what went well, what did not, what could we do better? You want to build those feedback loops. It isn't about finding problems, it's about making the entire process better. And if we see recurring findings or issues, we ask, how can we build this into the AppSec process from the beginning? And then we also, for us at AWS, we deploy mechanisms at scale. For every solution we develop, we ask, how can we build this for all of our services? Because this multiplies the impact of our security work across the organization. And each of these components must be measurable, repeatable, automated where possible, and they must be aligned with our business and customer objectives. And if you're a smaller organization and don't think this applies to you because of scale, It probably still does, but maybe just at like a different scale. It may not just be like the number of services you deploy, but also your builders. Not all developers write code, or it's not just that developers that write code. Consider who else in your organization will be using these mechanisms that you're building, and make sure they're included in those mechanisms. All right, I want to leave you with a few parting thoughts. I'm including the next couple slides because honestly, I do get asked this in every customer interaction lately. And the number one question I get is, are you going to replace your security engineers with Gen AI? And so I may have a little bit of a bias here. I am a security engineer, but I work in this space. And I think generative AI can amplify human judgment, but it's not going to replace it. Let me be clear about this. It's a powerful tool, and it is changing how we approach security, but it's not going to be the entire solution, and we still need human oversight. However, it does allow our engineers to focus on really interesting problems that only a human can solve. So when should we be using Gen AI? Which actually, are you guys using generative AI in your application security process? A couple, okay. So this is an evolving space, and we're going to see it change over time. So first, you might find utility in using something like Amazon Q for security tests to identify those test cases. Because remember, we were talking about like you want those security-focused tests, and you're going to use your threat model to identify those. But generative AI can be helpful in finding those specific tests and also finding the negative, right? Because humans are really good at creating test cases for happy paths or identifying like, yes, I do need to test this, but we forget to test the sad path or the negative. And generative AI can be very helpful in finding those. And you may also find use cases for identifying threats that you didn't think about before in your threat model. Now, I want to be really clear. This does not replace strong ownership and deep understanding of your service. But it may be helpful with asking the question, what could go wrong? But you still need that human judgment to determine if those supplied threats are actually applicable to your service. And I also find that generative AI makes a great assistant in the review process. It's really helpful for creating data flow diagrams, so you can get a really quick high level of like, what is this piece doing? And then also asking questions based off the code base that you want to dive deeper into. So you may know, like, working with that service team and working through the threat model, that we probably need to do some validation. And you can use generative AI to see if that's actually happening in that code, and it can point you to where you need to be looking really quickly. But you need to use your security judgment to, one, determine, is this truly effective? Is it working the way I expect it to? And are we doing this validation everywhere we need to be doing it? And all that said, keep in mind your results may vary based off the complexity of your application code, especially as you're working across multiple packages. But AI enhances, but doesn't replace security expertise. When combined with strong human judgment, it delivers better security outcomes. And then the very final takeaways. First, I've talked about this a lot, but culture is the foundation of how you scale. Builders own the services and the security of those services, and AppSec enables them. We don't own security for them. This mindset must start at the executive level and flow throughout the organization. And then create a clear escalation mechanism. This allows decisions early and gives visibility into the risk during the review process. And automation is how we scale. Look for every opportunity to automate routine checks and controls. This frees your security engineers to focus on the complex problems that truly need human judgment. And then use risk-based prioritization. This ensures you're spending your security resources where they have the greatest impact. And then capture metrics for visibility. If something matters, it needs to be measured and then improved over time. Because without data, you're just guessing at what is working and what isn't. And finally, build feedback loops for continuous improvement, because we're never done improving our AppSec processes. Thank you so much. I hope this was helpful. Thank you.